Hello everybody, I am Saurabh Datta. I am from ISOC India Kolkata chapter. This is a training initiative video. The training I have received from ISOC. The subject is building community network. In this video, I will describe what is community network, what is wireless networking standard, practical planning for implementing a wireless network, troubleshooting a wireless network, and securing network equipment. Thank you. So building community network, we have already discussed about the background. Now we are going to the basic part, that what is community network. The term community network refers to telecommunication infrastructure built and operated by citizens to facilitate communication, especially for internet communication. Community networks provide an alternative connectivity for internet access, and community network are do it yourself, built by the people for people. So why internet society promoting community network? Basically, in rural areas, either there is lack of internet connectivity, or there is not at all internet connectivity, or else the internet connectivity is there but it is not affordable. Another points are there. There is one more objective is create awareness about building community network or community networks, and develop people who can champion on community networks in their country through the local chapter. And mostly the internet society is working for an open, globally connected, secure and trustworthy internet for everyone. So this is the basic prerequisites to develop a plan for building community network. So we need to consider those things primarily when we are planning to develop or we are planning for building community networks. So there is a business development plan is required, MIS, technical expert is required for engineering, deployment, architecting, and also support and maintenance. Affordability of equipment is very important. We are planning for a community network, we are planning to build a community network, and we need to consider the cost of the equipments. Not only equipments, total we need to have a holistic idea for the transportation, logistic, equipment, power needs, cooling, internet link, like that. So I will highlight for the very critical most object factor is power needs in the rural area or a small villages in Himalayas. There is no normal power or electricity is available. Only solar power can be arranged over there, or air turbine can be implemented to generate the power actually. Another thing, we need to introduce some battery and inverters for continuity, power level continuity factor. Another thing is the cooling. Cooling is required to run the equipments, router or a switch or amplifier and whatever the equipment is there. Cooling is the factor to run seamlessly. Another thing is the uplink internet link. Where the internet is already terminated, we need to extend that internet link to that particular community, so that it will be the source of internet. Okay, and after that we can distribute it in the community. Position of a tower, we need to identify a particular position where the tower can be built and it will be the land that is owned by that particular community people. So we need to build awareness to those people so that they can um, provide their lands to build the build the tower, and maintenance and support. Maintenance and support is a very important factor to build the community network, because we can do so many planning. We can invest our capital to build the community network, but post when the network has been built, we need to maintain the network so that 100% uptime can be ensured, or 99% uptime can be ensured, and to make it reliable, trustworthy, and secure, the maintenance is required. So we are talking about the wireless community network, and mostly it is not the metro city, it will be the rural area, rural villages. So for traveling an engineer from the metro city to that particular location, it will be time consuming. Considering these factors, we can educate those community people to maintain and support their network. That's why it's called in the definition the build by yourself, people for people. So we can give the knowledge and technical knowledges so that they can support their own network. Say for example, there is a power circuit and there is this fuse cut. So they can identify the problem and they can repair a fuse, and the network can be restored. Yes, L1 and L2, level 1, level 2, level troubleshooting that community people can do itself. So this is our responsibility. So we can build the champion of the community network, and those people can be champion of that community network. So that is the whole idea and objective, and that is included in the community network planning. Sound business plan, we have already highlighted that BDM, Business Development Manager, will define a meaningful strategy of community network. What will be our objective? How we can build our community network so that it will be affordable of that community. It will not it will not so costly. That we need to think about. And human resources are required to build and maintain the community network. Logistics is required because we need to move the equipment from one state to another state. So permissions and insurance of those equipments is also needs to be under consideration. Transport is also required, and equipment we need to purchase the equipments also. We'll discuss about the equipment purchase policy. It's always recommended to purchase equipment from the nearest dealer so that supportability, transportation, the time, those factors, those parameters can be optimized. Time can be optimized, right? So those factors we will discuss later when we are going to practical planning and deployment of the community network. We'll definitely discuss on that. It's a very interesting factor. Wireless networking standards. So we need to know the standards. Why standards? And we are talking about community network that is solely based on wireless communication, wireless networking. So we need to discuss about wireless networking standards, and I will try to give some idea on wireless networking standards. So what is standard? The standards ensure that once the network has been added or introduced, wireless clients have the capacity to communicate with other network worldwide. So I am creating a network. The wireless devices are not able to talk to me. They are not able to identify the network, and it not make sense. So if we follow the standard, when we introduce a network, when we create or build a network, the wireless clients are able to talk to us, and that wireless networking standard, and the standard is built by IEEE. So that is Institute of Electrical and Electronics Engineers. So this is the portal standards.ieee.org, from where we will able to know about the standards, about the research about the standard those are in under development, about the standard those are already released. 900 standards are already released, and 400 standards are still under development. So we can refer this, we can go through this portal, and we can have the idea on the standard. So here the what is standard, it's demonstrated. There are open and closed standard. Open standard is free. Closed standards need to pay something. That's called BlackBerry Messenger and the Microsoft Office. See, for example, we can give that 802.11 is an example of open standard. So there are two basic things we need to know, that Ethernet standard and wireless broadband standard. IEEE 802.3 and IEEE 802.16. I have already discussed about 900 active standards that are already released, and 400 are in still development phase. This is the very interesting matrix of the standard, where we can identify the advantage and disadvantages of the standards and their internal compatibility with each other, so that different standards can talk to different standards. So it's and we can go to this particular livewire.com wireless standards, and there is a detailed discussion over there. We can refer the thing for more details. But 2.4 gigahertz and 5 gigahertz, the frequency we will mostly talk about for wireless communication. Okay. Some of the advantages are cost factor that we need to take under consideration, the speed also, data rate, and the disadvantages, interoperability. These are the factors we need to. For more information, we can refer the link. We can go through that. That's for all wireless standard, wireless network standard. In this representation, I am trying to establish that the 2.4 gigahertz band is become very noisy in urban area due to high elevation of the WLAN, and 2.4 gigahertz used 802.11b, 802.11g, 802.11n standard, and 5 gigahertz use 802.11a, 802.11n, and 802.11ac standard. So where 2.4 gigahertz is much more useful rather than 5 gigahertz, we can see this particular slide to get the proper understanding. And also there is a challenges for 2.4 gigahertz is our whole home appliances, like our micro oven, Bluetooth, It's also working on 2.4 GHz, so interference might occur and it will create interference and the communication may affect it. It's a naming convention. It is clearly demonstrated over here so that identify and isolate with each other about the standard Wi-Fi wireless fidelity WLAN and IEEE 802.11x. So that's all about the standards. Thank you for watching this video. We'll discuss about the planning for implementing a wireless network. It's a very important factor. In this discussion we will know how to plan and how to proceed for implementing a wireless network. So for planning, feasibility study is required, and then based on feasibility study we need to establish a link budget, and after that we need to consider other miscellaneous costs, and finally the implementation plan. So in the feasibility study we need to consider the weather condition, the temperature, rain, thunder, humidity, the time of those circumstances, and the characteristics of sand, soil, stones, the population where we are building the community network, access to road for the transportation because we need to move our equipment to the location, radio wave and tower we need to consider, condition for importing equipment, logistic also come into this point, communication factors we need to study, license and permissions. This is a typical website cis-india.org, telecom unlicensed spectrum brief.pdf. From here we can have an idea what frequency band can be considered for free in India, and it is always face-to-face discussion is recommended between the other stakeholders, and we need to have adequate time and go to the place, meet with the multiple stakeholders and build a written report in advance, so that in future the things can be referred for any requirement or any query. Baseline for feasibility study. In the feasibility study we can have couple of questions. Question number 1, what physical infrastructure is available? We can use the hill that surround the village as a home for the antenna. What technical infrastructure is available? I will need to source my own technical equipment. Where is the closest source of power and energy? It is very important factor. The nearest power station is not feasible to connect to, so the turbine and solar panel for power energy can be used. And where is the closest source of internet connections? The closest source of internet is 5 km away. So how to make the channel? So we need to use a cable to connect to the internet, so that connection will be treated as a uplink connections for my internet distribution point. These are the factors we need to consider. Some of the tools also we need to make it handy. That WebMon is a Linux based tool, is a free for 2.4 GHz frequency band. This can be used for the survey. we need to have a binocular to perform a line of sight test of the other endpoint, and the digital camera for the documentation of the site also. That is typically used for the tower to tower communications and the measurement of the distance. Use a blinking lamp or torch to communicate with the other node. Power source already we have discussed. The distance of the other point must be measured so that a proper link budget can be performed. To analyze a link budget, the distance is a factor. Accordingly, the antenna and the equipment will be sized. So this is also under sizing consideration. Tape measure, long light, rope, climbing gears are required to build the tower and put the equipment on the tower. The last point is very important. It's better to have a 5 extra meter of cable than miss 1 extra meter at the top of a 40 meters height tower. Very interesting. Questions. We can have these questions all time. The connection should be wireless. False. Not at all. Because we have the uplink consideration, right? We have the connections from internet, from the antenna to the base station, whether it will be a transmitting point or receiving point. If a cable can be used, that's supposed to be copper or fiber cable. Yes, it's true. The cable I cannot left on the ground as open. That's why the third point is treated as a false. And if using wireless, a single frequency channel should be set aside for use of this connection. Yes, it's true. So these are the considerations we need to keep on our mind. Establishing a link budget, this is a very important factor. A link budget is the accounting of all the gain and losses in a wireless link and ensuring the receiver can handle the transmitting power. The equation to work out the budget is the transmitter power minus cable length of transmission side plus antenna gain minus free space loss plus antenna gain at receiving side minus cable loss at receiving side equal to margin minus receiver sensitivity. So in the next slide we can have a clear idea on that. Here the transmitter is having the power of 18 dB. Transmitter to antenna that is connected between a cable. Transmitter and antenna is connected through a cable, and in between the cable is creating a loss, that is transmitter side cable loss is minus 75 dB. Again, that antenna is creating a gain that is stated as a green color, that is 30 dBi, and between one antenna to another antenna, means transmitter side antenna to receiver side antenna, there is a free space. So the free space is creating a loss of the signal. The amount of loss is 120 dB, so it's minus 120 dB, and then again the receiver side antenna is adding a gain, so that is plus 20 dB plus, in the receiver side cable loss is 6 dB, so it's minus 6 dB equal to the margin. That's margin is coming like minus 65.5 dB, and the receiver side sensitivity is minus 82 dBm. So if we put this equation, the resultant is coming like plus 16.5 dB. So here the calculation of a link budget, and we can see the total radio link budget is 16.5 dB, and we need to know about that distance is 10 kilometer, and the frequency we have chosen 2.4 gigahertz, and the standard we are using IEEE 802.11b. This is a case study of a 40 kilometer distance with the frequency 2.4 gigahertz, and here also the factors are considered the same way, where we have discussed in earlier slide. Here also the free space loss is minus 131 dB. Same, the order are same, and the formulas is like this. If I go to here, this is the formula, and the link budget is plus 16 dB. Okay, so here other miscellaneous costs. Other miscellaneous cost means the equipment and equipment health and the power source. We are using the battery charger, AGR means automatic voltage regulator, and inverter, because to make the unstable power to stable, because in the rural area the power is not stable, and that is very harmful for any equipment, and the demand for electricity is more than what the provider can deliver. The situation is many of the country is not stable enough to directly plug electronic equipment into the grid power outlet, as the power may be fluctuating. So we need to think deeply to prevent our equipment. These backup systems are relatively inexpensive and are very effective in providing the both surge protection and consistent power supply. So we can use those. And battery also treated as a continuity factor. If the power is not there, it can be used for continuing the equipment as a operational. Lightning is an enemy of any electrical and electronic equipment, so we need to keep our eyes on those factors, how to protect our equipment from lightning. So this slide is explaining the thing. There are two types of hit can occur, the direct hits and indirect hits. These are the miscellaneous costs over here: the tools, local transport license, permissions, tower, local procurement. I have already discussed and always recommended to do the local procurement to get the benefit of the service and the equipment. Transport is very important factor. Permissions and license, that also I have demonstrated in earlier slide. We need to take the permissions from the landowner also, who can give their land or permit to build the tower and put the antennas over there. These are the things. Procurement of equipment. Procurement can be done locally within the country or be imported. Choice should be depends on bandwidth, range, support, operating frequency and availability. Local procurement is there. Another thing is the weather. It is recommended to in equator, hottest seasons and rainy season periods supposed to be avoided. Avoided the cold and wet winter in European country. These are the quality assurance factor. We need to jitter, uptime, signal to noise ratio, throughput, packet plot, duplicate packets, and round trip. Antenna tip, that is for the curvature of the earth. That the equation is there. You can consider like this. That's all, and it's a challenges in India. That's all. Troubleshooting a wireless network. So, if we are able to successfully build a wireless network, that means we need to concentrate on our troubleshooting factor actually. Because if the network is there, then problem will occur, and when problem is occurred, then we need to resolve the problem. In this slide, we are able to see the common problems on a network. I can't send my emails. Somebody is telling my internet connection is really bad. Somebody is not able to log into the internet. So we can discuss on those aspects. So when we are going for troubleshooting, we need to know about the OSI layer, because if we know the OSI layer, we easily understand the problem area and we'll be able to resolve the problem. Okay. So problem with a wireless network are often invisible and can require more skill and more time to diagnose and provide the resolution. Interference, wind, and new physical obstruction can cause even a long-running network to fail. So we need to consider each and every aspect when any problem occurs and when we are going to resolve those problems. So here is the idea about the OSI layer: the physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and then application layer. So you all are users are working on the application layers. So initially, whatever problem we are reporting or we are facing, somehow it is apparently related to the application layer. But problem can be appear in application layer, but actual problem cause might reside in some other layer. So we will see how we will able to identify the problem and how we can resolve the thing. There are basic two examples. Why can't I access the internet? Second is, things work sometimes. The previous thing, things do not work at all. And second thing, why is my computer sometimes so slow? Means sometimes it's working fine. So classifying the problem is not an easy task. Okay, methodology we need to know to troubleshoot the problem. Actually, there are key factors is identify which layer the problem appears in and identify which layer the cause of the problem. So somebody is saying that I am not able to open my mail or Outlook. That means problem is happening with the application layer. But as a user I am facing the problem in application layer. But that is not always true that the problem is residing on application layer. It might be in its physical layer. However, during the diagnostic we can able to see that the network cable is not at all plugged. That's why the mail application is not at all working. So the user is receiving a wireless signal but is still not connected to the internet. It may not arrive because the computer doesn't have the IP address, right? And this problem is caused in network layer. Might be the cable is not connected, that means problem is related with the physical layer, but the end user is getting the problem from the application layer. Now during the troubleshooting, we need to concentrate on this particular things. We need to keep in mind in these particular things. First, don't be panic. Problem, if it's a network, if any technology, problem can be occurred anytime. Okay, so don't panic. Is it plugged in? The equipment is powered on at all. Okay, so that we need to check. Last thing, change. Is there any last modification or last change happened in the system, in the architecture, in the network, in any equipment? Do we have a backup of the configurations? Okay, the known good, you have to have a known good equipment. Say for example a mounting cable. Okay, say for example we are suspecting there is a cable might be a fault. The faulty cable is faulty, so we have a working cable, known working cable, that is a tested, that cable is working. So we can replace the faulty thing, suspected faulty cable, with a working one, and we can see whether the problem is resolving or not. If it is not resolved, that means we need to look some other area. If it is resolved with our working cable, that means that problem cable was faulty. Change one variable. So don't change multiple things in a problematic network. You are doing some configuration change in router, you are rebooting a equipment, or you are changing a cable and you are rebooting a router, then you check whether the connectivity has been established or not. You are rebooting your client system, you are flashing the DNS configuration of your client system. Simultaneously, don't do multiple changes, only single changes, and you check single change and check whether the things is working or not. Do not harm anything. If you don't fully understand how a system works, don't be afraid to call in an expert. If you are not sure if the particular change will damage another part of the system, then either find someone who more experience, or you need to discuss with your senior. Putting a penny in place of a fuse may solve the immediate problem, but it may also burn down the entire building. So be careful when you are going to troubleshoot any problem. There are two types of problems generally we found. Things do not work at all. Things work sometimes. That means intermittent problem is happening. Intermittent problem is very critical. Methodology for troubleshooting. There are a couple of approaches there. Bottom up troubleshooting. So we have started identifying the problem area from physical layer to application layer. Means user is telling that I am not able to use my email, or I am not able to use my messenger. So what we need to check? Blindly we can check whether the network layer, physical layer is working fine or not. Then we need to check whether the system is having the IP address or not. Can we reach to the router or the gateway? After that, are you able to authenticate the transport layer? Then can we reach out the internet site? Means can I open the Google from that particular machine? After that, if it is not, then we need to check the proxy settings, and after that, what things what program is giving the error. There might be some settings is needs to be required in the particular application. I am able to open the Google, but I am not able to open the Hotmail, right? It can be. Second is the top-down troubleshooting, checking the application configurations, and then you come to the physical layer. So this is the what program do you use to check your email application layer. Then again you come to the proxy settings, then other internet site application. Are you able to authenticate? Then are you able to ping the router or other device? Do you have an IP address? If your wireless equipment is working, the green indicator is glowing or not. These are the factors. Is there any amber LED is showing? Those are the things needs to be checked. The most common methodology is middle top-down troubleshooting. First, if any problem occurred, okay, simply we are pinging the router or we are pinging the gateway. So if I am able to ping the gateway, that means up to network layer I am okay. I am able to ping, that means up to network layer I am okay. After that we need to go to the above layers, transport layer, session layer. So Hotmail is not working, so I will try to ping the gateway. Yes, gateway is pinging. Now I am trying to ping the Hotmail. Hotmail is not pinging, that means what happened? Might be DNS is having problem, so it's not able to resolve the name of the Hotmail, the name of the IP address of the Hotmail, that's why it is not able to ping. If the DNS is working fine, still I am not able to ping the Hotmail. We don't need to conclude that there is a problem, because might be ping protocol is disabled from the Hotmail data, where the data center and the firewall behind the Hotmail is hosted. So we need to do the curl command, https curl/https://hotmail.com or telnet hotmail.com space port https or 443, so that we can check whether the connectivity is being established or not. So in such a way we can do the troubleshooting of the very common approach, actually, middle top down troubleshooting. The most times this is only helps to identify who to blame rather than the troubleshooting the actual problem. If ping to the router fails, then you can blame the wireless carrier. If ping to the service fails, then you can blame the international carrier. If none of them fail, then you blame to the user or operating system. So if ping to the service and the router is unsuccessful, the next set of questions to ask is, do we have an IP address? Have we authenticated with the access control server? Once we will able to successfully authenticate to the access control server, then only we will get the IP address. The IP address will be obtained by the system, and then the authentication within the ping can be happen. Otherwise, ping will not happen. So this is the three methodology, actually: bottom up troubleshooting, top down troubleshooting, and most popular middle top down troubleshooting. So hope you all enjoy the troubleshooting aspects. We are all doing the troubleshooting, and here is the background of that. Thank you. Securing network equipment. So we have already discussed about the building community network and the network standard, planning of the community network and the implementations. After that, we have discussed about the troubleshooting steps for the wireless network. Now we are discussing about the security. So why security is required? Security is required to ensure that our network, the wireless network, is reliable, and it will also ensure the sustainability and the stability of the network. So we need to secure all the components. Those are the physical security and the other security aspects also. So we'll discuss in this presentation about the securing network equipment. So when we are discussing about the security, we need to know some of the terminology for the security and threats, security threats. So here, information gathering, sniffing, spoofing, session hijacking, and denial of service. These are the factors we are highlighting. So information gathering. Say for example, I am using a router, and from external client, I am able to identify the version of iOS of the router, and from knowing the version of the router or iOS version, I will be able to know the common vulnerabilities of this particular iOS, and I can start the attack. Sniffing. Sniffing is kind of a information gathering also. So there are two systems are communicating between each other, and from somebody from the network, it's capturing the packets, and it's taking the data from those packets. So packet can be captured, but if the data is not encrypted or not secure, we can simply read the data. Say for example, we are using some portal, and the portal is not HTTPS, it's working on http:// It is not HTTPS. Say for example, I'm giving the Gmail, I'm giving the username and password, and somebody is sniffing the packet from the network. We'll be able to see my username and password simply. Spoofing. Spoofing is one of the type of attack actually. What is happening that I am having one web server, and I am getting the request from the client, and I am sending it back to the client, the response. So if someone spoof my IP address, and he can create a replica of my web server's name and all those stuffs, and once the request is traversed to the network, that hacker or attacker by spoofing can represent as my web server, and he will provide the fake information to the requester. Another thing is the session hijacking. See, if I'm doing a transactions with the client and server, so and third party attacker or hacker can be hijack the session, and you will start the transaction on behalf of my systems, and the inter communication will be compromised. The last thing is denial of service. Denial of service is, it's a common kind of attack. Say for example, I am running on HTTP or HTTPS or some other service. So attacker can initiate multiple packets towards my server. So what this three-way handshaking is happened, that seems in an acknowledgement. So they are sending the scene packet continuous basis. And my server is sending the scene action. They are not acknowledging the final confirmations. So the server is continuously sending the CNAC packet continuous basis, and it is still awaiting for the acknowledgement from the client. This means time to time the server load is getting increased, and it will stop the service. It will not able to respond with the legitimate requests. So that's kind of a denial of service attack. So we need to think about those kind of occurrence or probability of the occurrence, and we need to ensure the security so that these kind of things can be prevented. And these are the things can be prevented in router, switch, the peripherals equipments also. So in router consideration, router is the very first line of defense. So it provides the packet routing, and it can also be configured as a block or filter the forwarding of the packet types that are known to be vulnerable or used maliciously, such as ICMP or SNMP. If you do not have the control of the router, there is little you can do to protect your network. You are asking your ISP what defense mechanism they have in place, their routers. So the basic practices, the best practices are that the patch and updates, you keep updating, you keep patching, be paranoid and continuous patching. Don't miss any patch and update. Protocols, unwanted protocols supposed to be blocked. Administrative access, you have to restrict your administrative access, and we will also recommend you to two-factor authentication or MFA multi-factor authentication. So your administrator can, when log into the router, it's supposed to be have the MFA multi-factor authentication so that you can get into the router. Another is the service, unwanted services running on the router supposed to be blocked. Auditing and logging, you need to enable auditing and logging of the routers and what activities has performed when for the historical analysis and forensic, and intrusion detection if any attacks are happening or any malicious things are happening or some failed attempts are happening to login. There is supposed to be a mechanism to trigger an alert or SMS so that you will be alerted that something is going wrong. So snapshot of secure network, router, firewall, switch and others. Router, we have already discussed the protocol, administrative access, strong administration password, web facing int administrative is disabled, service, unused the boot ES finger service, these are the unused service needs to be disabled. IDS I already told, login and monitoring also. Firewall is the same kind of thing, patches and updates, it's all time it's recommended. Filters, the packet filtering policy, block all but required traffic, all block and desired packet will be allowed. Login and auditing, the same thing whatever we have discussed. Perimeter network is a place is a multiple network required access to servers. Firewall is a place between the untrusted networks, and only those ports are all protocols and ports are required to be allowed. Specifically, please allow those ports, not all ports. Okay. If you can do a netting to hide your actual server IP, firewall can do. Please, we are recommending to do the netting with your any public IP so that your actual backend server's IP will be hidden. Switch, patches and updates is there is another layer is a VLAN. We can segregate the traffic flow through the VLAN so that one VLAN is compromised, other VLAN cannot be. This kind of segregations we can do. Login and monitoring is nothing to say new. All the things, minimum administrative interface access controls are configured, and secure SNMP community needs to be established. SNMP v3, not v2 service. Unused services are disabled. Switch traffic is encrypted. You can enable encryption on the switch level so that traffic can be encrypted. Other area including the admin workstation, this is a very critical thing. We are doing all the security in all the network equipment, say for routers, switch, firewall, proxies, DNS, all the appliance. Very good. But do we think about our endpoint? From which desktop or which laptop I am going to log into the router to do the administrations? Do we have the proper security mechanism to protect that particular workstations from where I am doing the administrative task? I am performing the administrative task. If we do not have, then we need to implement it right now. Be paranoid and try to implement the security aspects and security best practices on those workstations. Endpoint security management is covered in this chapter. Reporting and dashboard. Through the reporting and dashboard, we can have the entire holistic view and the details view with the Tableau and dashboard format of that all clients. Discovery, we can discover all the clients. Whenever any client is attached in the network, it will be automatically discovered. Spyware blocking and removal. The antivirus server software is supposed to be there. Properly inventory needs to be mapped. Inventory needs to be maintained. Patch management. Again and again we are discussing about the application blocking. On unwanted applications supposed to be blocked. Connections control mechanism. We can put a rate limit over there. If any huge connections has occurred, it's supposed to be blocked. Also the rate limit can be introduced on firewall also. Network access control supposed to be there. Antivirus auditing and enforcements. Audit compliance enforcements. That system supposed to be comply the audit. We have some tools through that we can download the current signature from the CIS. We can map it with our signatures, and we can scan the systems and we can check the status of the compliance status. Post intrusion preventions, we can HIPS, we can put over there, we can check, and we need to have the strong password policy. We need to have the tight group policy so that we cannot do the administrative task. We cannot do the changes in the registry as and when required in all those stuff. This kind of restrictions supposed to be there. We need to enable the tackles and radius authentications so that MFA can be there. So see, all clocks supposed to be synchronized. That is very critical point, that we need to maintain this clock synchronizations or maintain our router, switch, firewalls and all other appliances, and we need to have a steady state NTP configurations, and NTP needs to be deployed over there so that all time can be synced. That's all about the security aspects of the network equipment and the workstations from where the network equipments will be managed. So that is the end of the discussion. Thank you very much.